Hello class, today we are going to look at solving right triangles. Alright, so what does it mean to solve a triangle? Alright, what this means is you're going to find all of the side lengths, all of the angles, everything. All three sides, all three angles. Now for this to work you have to have three things. Now this says two things, but you have to have three things. One, you have to have sides, angles, you have to have at least one side. Okay? You have to have at least one side, and then you have to have some more sides and angles, something like that. Three. Now, in all of these, we're already going to know one thing, and that's going to be that it is a right triangle. So we already know one angle, we know the right angle, and then in addition to that, we have to know either two sides or one side and one of the acute angles. Okay? Doesn't work if all you have are angles. Right, because we saw that before. That was angle-angle similarity. You know the angles are the same, but everything else is in flux. So, now, to do this, obviously we're going to have to find sides. Well, we already know how to do that. We could use Pythagorean theorem to find the sides, or we could use trigonometric ratios, SOHCAHTOA, sine, cosine, and tangent, to find the sides. How do we find the angles? Because we also have to find the angles for this. All right, and so that brings us to the inverse of the trigonometric ratios. All right, so the inverse ratios. That would be inverse of tangent, inverse of sine, inverse of cosine. Okay, most of your calculators have this as tangent to the -1, sine to the -1, and cosine to the -1. But they are inverse tangent, inverse sine, inverse cosine. You may also see them referred to as the arctangent, the arcsine, the arccosine. That's how it is on my phone. The calculator on that, it may have a tan, a sine, a cosine. That's arcsine. Same thing. And what this does is this is the inverse. So for example, if you have the tangent of a equals x, then the inverse tangent of a is the inverse tangent of x is the measure of angle A. All right. So let's take a look at this. It'll make more sense as we do some of these. So we've got some sample problems here. First, determine which of the two acute angles has the given trigonometric ratio. All right. So on number one, we have the cosine of some angle is 24/25. All right. So let's focus. There we go, get a little bit better focused. So 24/25 is the cosine. Now, if you remember, cosine is adjacent over hypotenuse. It's the CAH from the SOHCAHTOA. So that means 24 must be adjacent and 25 must be hypotenuse. So there's 25 hypotenuse, and 24 is adjacent to F. So the cosine of angle F is 24/25. All right. Let's see. The sine of some angle is approximately 0.38. Let's see here. Well, let's see. Sine is opposite over hypotenuse, right? Problem is we don't know, is it opposite of E or opposite of F? Okay, so opposite of F, we would have 2√3 over the hypotenuse, which is the square root of 14. Opposite of E, we would have the square root of 2 over the square root of 14. So which of those is going to be approximately 3.8? Well, let's find out. Let's see, we'll just start with E first, because why not? So we have the square root of 2, out from underneath the square root there, divided by the square root of 14, and we get here the sine of E is approximately 0.378. Yeah, that looks pretty good there. Let's just double check that one. So we have 2 square roots of 3 divided by the square root of 14, which is, 9.925. Yeah, that ain't a good bit. So it's going to be E. Angle E is the answer. All right. Easy enough. Let's see. Exercises 3 through 6. Let H be some acute angle. Use the calculator to approximate the value of the measure of angle h to the nearest tenth of a degree. So all we're going to do here is use the inverse ratios. So if the sine of h is 0.02, we want to get rid of the sine. So we want to undo sine, and so what we have is the sine inverse. Sine inverse. And that's going to cancel out the sine. So we're just left with h is equal to the sine inverse of 0.2. So that's what we're going to type into our calculator here. We have sine inverse of 0.2, and we end up with 11.536. So we want this to the nearest tenth of a degree, so 11.5. So the measure of angle h is approximately 11.5 degrees. All right? Pretty simple stuff, really. So how about you do 4, 5, and 6? Pause the video, get your answers, come back, see how you did. All right, let's see how you did. So this is tangent of h equals 1, so we're going to do the inverse of that. So that means the measure of angle h is equal to the inverse tangent of 1. So inverse tangent of 1 is 45. And hopefully you remember that is 45 degrees. All right. Let's see. Next we have cosine of h is 0.33. So we're going to do the inverse cosine. So the measure of angle h is equal to the inverse cosine of 0.33. So that means the measure of angle h is, let's see here, the inverse cosine of 0.33 is 70.73. So to the nearest tenth would be approximately 70.1 degrees. Sorry, 70.7 degrees. Okay. And here we have the sine of h is 0.89, which means the measure of angle h is equal to the inverse sine, or the sine inverse, the arc sine of 0.89. So let's see here. Arc sine, inverse sine, whichever you want to call it, 0.89. 62.87, so that'll round to 62.9. So the measure of angle h is approximately 62.9 degrees. That's easy stuff. Just stick it in the calculator, right? All right. For the rest of these, we want to solve the right triangle. Round decimal answers to the nearest tenth. Okay. So solve the triangle means find all of the angles, all of the sides that we don't already know. Well, we know two sides. We know it's a right triangle. So those are three pieces that we know. We got to find the other three pieces. So we need the measure of angle A, the measure of angle C, and the length of AC. Easiest one to do is the one that we've been doing for the longest, and that would be Pythagorean theorem. I know two sides, I can find the third. So AC is equal to the square root of 6 squared plus 12 squared. All right, let's see what that is. Square root of 6 squared plus 12 squared is 13.41, which we want to the nearest tenth, so that would be 13.4, approximately. So AC is approximately 13.4. We can go ahead and put that down here, 13.4. Answer number 1. Now we got to find the angles, right? So what we're going to do is we're going to use SOHCAHTOA. We're going to use the inverse. If you're looking for the angles, you're going to use inverse. So we're going to use the inverse of sine, cosine, or tangent. Well, let's just start with angle A. Why not? So A, which sides do we know? Well, we actually know all three of them. However, this 13.4, that's an approximation, and we really don't want to use approximations if we don't have to. Sometimes we do, but we'd rather not. So we're going to use the 12 and the 6. All right, let's see, 12 and 6, that's opposite, that's adjacent, so this is TOA, so we're going to be using tangent. So the tangent of A is equal to opposite 12 over adjacent, which is 6. Okay, so 12 over 6 is 2. So what we end up with is the tangent of A equals 2. We don't want the tangent of A, we just want A. So we have to undo the tangent. So what we're going to have is the measure of angle A equals the inverse tangent of 2. Let's find out what we've got. So inverse tangent of 2 gives us 63.43, rounded to the nearest tenth would be 63.4. So the measure of angle A is equal to 63.4 degrees. All right. Go ahead and put that down here, 63.4 degrees. Now we need to find the measure of angle C. So a couple ways we could do this. We could do tangent again, right? Inverse tangent of 6 over 12, or since we know that these two angles add up to 90 degrees, because all three of them are 180, this is 90, so our acute angles are 90 degrees, I could just take 90 degrees minus 63.4, which is what I'm going to do. So 90 minus 63.4, and I'm not actually going to use 63.4. I'm going to use 63.434948882, the whole thing. So 90 minus, second answer, gives me 26.56, which rounds to 26.6. 26.6 degrees is equal to the measure of angle B. 26.6 degrees. And just so you can see this, so we could do this the other way around. Let's see, that tangent would be 6 over 12, right? So inverse tangent of 6 over 12, no, it is not actually necessary to simplify in your calculators. And we get the exact same answer. All right, so we're good. Let's do some more. All right, let's see here, number 8. Number 8, we're still solving. We have two sides. We have the right angle. We need to find the two acute angles, and we need to find that other side. So easy enough. Again, we have two sides looking for the third side of a right triangle. That is, of course, Pythagorean theorem. So let's do that. So the length of ED is equal to the square root of, now this time they gave us the hypotenuse, so it's going to be 75 squared minus 21 squared, which means ED is equal to approximately square root of 75 squared minus 21 squared, 72. Not approximate, exactly 72. That's always nice. Pythagorean triple right there. Now we got to find our angles. So we're going to do the same thing. Now we could use tangent again using the 72 since it is an exact answer, it's not rounded, or we can use the numbers they gave us. Let's see. We'll use C because it's first alphabetically. Why not? So C, we would have 21, which is adjacent, and the hypotenuse, which is hypotenuse. So 75, which is hypotenuse, so adjacent and hypotenuse is cosine. So we have cosine of C equals 21, the adjacent, over the hypotenuse of 75. We don't want the cosine of C, we want C. So we do the inverse cosine, inverse cosine of 21/75, I'm not bothering to simplify this, equals C. So let's see what that is. Inverse cosine of 21 divided by 75 is approximately 73.73, so to the nearest tenth, 73.7. So C is, the measure of angle C is approximately 73.7 degrees. So I'm going to go and write that here, 73.7 degrees. And to get angle D, we're just going to take this and subtract it from 90. So 90 minus 73.7. So 90 minus, answer is 16.26, which rounds to 16.3. 16.3 is the measure of angle D. 16.3 3 degrees. And now we know all 3 angles and all 3 sides. Right. Let's take a look at number 9. Number 9. Oh, this one's a little bit different. Number 9, they did not give us 2 of the sides. Instead, they gave us 1 side and 1 angle. So will we be using Pythagorean theorem here? No, we will not, because that takes 2 sides and we only have 1. So, easiest thing to do here would be to find this angle, right? Because over here, how did we find that missing angle once we had that one? Yeah, we just subtracted from 90. So let's do that. So 90 minus 52, that's 8, 7, 8, 9, so that would be 38 degrees. And this will be the measure of angle, which one is this? N. Measure of angle N is 38 degrees. 38 degrees, not rounded, exact answer. All right, now we need to find these other 2 sides. Well, that's easy enough. We've been doing that last couple lessons. This is going to be SOHCAHTOA, right? Sine, cosine, and tangent. Well, let's just use our 52 because that's the one we were given. So if I'm looking for LM, LM would be adjacent to my 52. And 3, the one I know, that is across from the right angle, that's the hypotenuse. So we have adjacent and hypotenuse, that is cosine. So what we have is the cosine of 52 degrees equals adjacent, I don't know, LM, over hypotenuse, which is 3. Since the known information is on the bottom, we're going to multiply this. And so LM is equal to 3 times the cosine of 52 degrees, which means LM, let's find out, 3 cosine 50, what was it, 2, is 1.84, which to the nearest tenth would be 1.8. LM is approximately 1.8. 1.8. So now we need NM. And we could use Pythagorean theorem. We do have 2 answers here. However, this is not exactly 1.8. In fact, it's not exactly 1.846984426 either. Even that is rounded off. So we don't want to use it because it's not the exact answer, which means it won't give us, it'll be off. Right? So instead, that's fine. We'll just use sine, opposite in hypotenuse. So it's not a big deal. So let's see here. Sine of 52 degrees equals opposite MN over hypotenuse, 3. Again, we're going to multiply here. So MN is equal to 3 times the sine of 52 degrees. Instead of the cosine, we're using sine this time. 3 sine 52, which is 2.36, so approximately 2.4. So MN is approximately 2.4. Right? 2.4. I haven't been checking, but let's check these real quick. Opposite the right angle, our hypotenuse is the longest side, yes? Yes. And the smallest angle is opposite the smallest side. So we're good. And we have all 3 angles, all 3 sides. Triangle is solved. Okay, so next one, number 10. I would like for you to pause the video, work this one out on your own, see how you do. Okay, you're back. Let's see how you did. Let's see, we have an angle and only one side, so we are not going to be using Pythagorean theorem to start off with here. Instead, we are going to do this like we did on number 9, and we're going to find this missing angle, which is easy enough to do. It's just 90 minus 29. That's 1, that's 8, so that'd be 61 degrees. 1 degrees, and this is the measure of angle Y. Okay, so now we got to find our sides. So let's see, what do we have? We have the opposite, and we'll just find ZX first, because why not? We can do whichever one we like. So ZX is adjacent, so that's opposite and adjacent, which is tangent. So tangent of 29 degrees is equal to my opposite, 18, over my adjacent, which is ZX. Don't know what that is yet. Okay, so here my variable is on the bottom, so we're going to divide. So zx is equal to 18 divided by tangent of 29. And so zx is, let's find out. Cover my thing, what am I doing? 18 divided by the tangent of 29. 18 divided by tangent of 29. 34.47, so that will round to 32.47, so that will round to 32.5. Zx equals 32.5, approximately. 32.5. Okay, so now we need zy. Now I'm still going to use the 29 because it's the one that was given to me. I could use the 61. Yeah, you know what? Let's use the 61 because why not? It's an exact number. It's not rounded off, so we can use it. So 18 is adjacent, and we're looking for zy, which is the hypotenuse. So adjacent and hypotenuse would be cosine. So cosine of 61 degrees is equal to adjacent of 18 divided by the hypotenuse of zy. So again, we're dividing here, so we're going to have zy equals 18 divided by cosine of 61, which means zy is equal to approximately, let's see, 18 divided by cosine of 61. There we go. Always nice when the bell interrupts us. And that is 37.12, so approximately 37.1. 37.1. 37.1. Again, longest side opposite the right angle, shortest side opposite the shortest angle. All right, one last problem and we are done. A boat is pulled in by a winch on a dock 12 feet above the deck of the boat, as shown. The winch is fully extended to 25 feet. We want the angle of elevation. The angle of elevation is going to be this angle right here. That is what we are looking for. So, since we're looking for an angle, we are going to use inverse of one of our ratios. Let's see which one. Let's see, we have 12. That is opposite the angle. We have 25, which is the hypotenuse. So opposite and hypotenuse would be sine. So sine of x degrees is equal to opposite of 12 over hypotenuse, which is 25. So we're going to do the inverse, and so x is equal to the sine inverse of 12 over 25. So we'll see what that gets us. Let's see here. So sine inverse of 12 over 25. 28.68. Does it say what to round to? It does not. Everything else has been tenths, so we'll go with tenths. So we'll say 28.7 degrees. So x is approximately 28.7. All right. So there it is. Solving a triangle. Find all the missing pieces, all the angles, all the sides, find everything. Sides, you're either going to use Pythagorean theorem, or you are going to use your SOHCAHTOA, sine, cosine, and tangent. For the angles, you will either use the inverse sine, cosine, and tangent, or you will just subtract the known angle from 90 degrees. All right? Easy enough to do. Hope you found that useful, and I will see you next time.